So welcome back to my series of short video about manual J load calculation. Hopefully you've watched my previous video by now and you know what a load calculation is, what it does, and how to take advantage of a load calculation to increase the efficiency of your house. And actually today what I want to do, I want to compare that 30-year-old house that we retrofit and we turn into a high performance house by replacing the windows and making the attic part of the conditioned space, so now the duct are inside the conditioned space. And I want to compare that house to a house built in the 2009 energy code specs. So identical house but built with the 2009 specs. And I want to compare the two and see which one is more efficient. So here, this is all of 30-year-old house that we retrofit. Okay, so we replace the aluminum windows for vinyl windows and we move the duct inside the conditioned space. Okay, so we're still in Dallas-Fort Worth. Okay, we're still the same data. If you've watched my previous video, you know the house. So we've got concrete slab, R21 of insulation in the attic. The wall, we still use those 2x4 wall with R13 of insulation between the stud. And then we now have the vinyl window that we replaced from the original aluminum windows. So the other thing that we had done in the house is we had moved the duct. Originally the duct were in the attic, we moved them inside the conditioned space, or we made the attic part of the conditioned space. If you watch my previous video on duct inside the conditioned space, I explain how you make the attic part of the conditioned space. And then we did not touch the air infiltration because also on the previous video we've seen how air infiltration doesn't offer the greatest benefit for this region. So we decided to save our money, and instead of spending money on try to stop air infiltration, we're going to save that money and we spend that money on replacing the windows and conditioning the attic. Okay, so now when we look at the load, this is the load for that retrofit house. So in the summer, 40,000 BTU of heat is entering the house, and in the winter, almost 62,000 BTU of heat is leaving the house. So now we're going to take the house and we're going to take the same house, but we're going to build it to 2009 energy code specs, and we're going to compare the two and see which one is more efficient. Okay, so now that's the same house, but we are using the 2009 energy code requirement for the Dallas-Fort Worth area, vented attic, duct in the attic. So we're still in the Dallas-Fort Worth area. Okay, so a few things have changed. Mainly, okay, the floor is the same. We still use a concrete slab. The attic insulation for 2009 changed. We had to use R30 of insulation 9 on the attic floor. So we went from R21 to R30. Now the wall is the same. There was no change, no special requirement for the wall. So 2009 you can use 2x4 with R13 of insulation between the stud. And then on the 2009, the specs for the windows, you can still use aluminum windows. So we went back and we used the same aluminum windows. Now what changed in 2009 was air infiltration. And that was the first time it was introduced in the code, at least for this region. So air infiltration requirement for 2009 is 7 air exchange per hour, 7 ACH. So that gives us, on the manual J translation, gives us about an average construction type. So I moved the infiltration from loose on the 30-year-old house to average for the 2009 code house. Okay, but the duct, no requirement for the duct. So the duct are in the attic outside the conditioned space. Okay, so now when you look at the load on the 2009 specs, it is. So in the summer, 45,826 BTU of heat is entering the house, and 65,514 BTU of heat is losing the house. So how does it compare to our retrofit? Well, there we go, side by side. So this is the 2009 house. Okay, so in the summer, 45,826 BTU of heat is entering the house in the summer. On the retrofit house, only 40,000 BTU of heat is entering the house. So our retrofit is more efficient in the summer than the 2009 house. Now if you look in the winter, the 2009 house is losing 65,514 BTU of heat, and our retrofit is losing 61,987 BTU. So we are also more efficient in the winter. So here, our retrofit, our 30-year retrofit, is actually more efficient than the 2009 specs house. Now there is one change, and if you looked at my video about air infiltration, we talked about how air infiltration helped to stop the humidity from entering your house in the summer. And if you look at the latent heat, see on the 2009 house, our latent heat, so we are gaining 4,931 BTU of humidity in the summer. In our older house where we did nothing to stop the air infiltration, 5,446 BTU of humidity is entering the house. So our 2009 house is a little bit more efficient in that, but the numbers are so small I would not worry about it. So again, only the manual J could give us all this information. So remember to order your manual J. Go on my website, go at the bottom of the page, and here I've got all the information that I need to do a manual J. So thank you again for watching my video, and I hope I will see you in my next video.